Number 3, find the surface area and volume of the given cylinder. Let's make sure we read these red directions here. On the bottom, they're red, so they must be important. You need to rewrite each equation and show the numbers being plugged into the equation. You need to show all your work to get credit. Oh, okay. So we know that. We don't need those red directions to tell us that because we are good on that. So let's start with the volume. I think the volume is actually easier than the surface area. And the formula that I'm going to use is that it's going to be that radius squared times the height. Radius squared times pi times the height. So again, what we want to do is just plug in. And this is what those red directions are saying. They're saying, hey, just make sure you're doing what you've always been doing. So we know that you know how this works. And we know that. So let's see. We need to find what the radius is to plug in. So remember, the radius is only halfway across the circle. So here it is. Here's the radius. It's halfway across. So remember, diameter is the full way across. So you always want to be careful with that because if you put the diameter in instead of the radius, you're going to get the wrong answer. So I cannot stress enough how important it is to know radius from diameter. So we're going to plug in, don't like that parenthesis, let me fix that. We're going to plug in 4.3 squared times pi and then times the height, and it does give us the height of the cylinder right there, which is 8.6. So guess what? We have plugged all of our numbers into the equation just like it told us to do in the red directions. And all we have to do now is calculator work. So we're going to do parenthesis 4.3 and parenthesis squared. Scroll out of the exponent. Pi, you want to make sure you're using that pi button, parenthesis 8.6 and parenthesis enter. All right, so we get 499.5572142, but we just went around to the nearest hundredths. So that's going to give us a decimal approximation. We want to use that squiggly equal sign because it's not exact, and it gives us 499.56 inches. Now remember, this is a 3D figure, and we want to know how much will fit inside. So that's going to be cubed. Volume is always cubed. I know when we talk about area, we say area squarea. In 4 years, I've not been able to come up with a clever rhyme for volume and cubed. But if you come up with anything, let me know. All right, that's half of it. So we're done with half. If you want to write it in up here, you can. I guess you can't, but I can. So, all right, let's take a look at the surface area now. So surface area, keep in mind you don't have to have these formulas memorized. It's always handy to be able to have it, in your notes or somewhere that's easy accessible, or easily accessible when you're working with these types of problems. So our surface area formula is 2 pi r squared. Now pi r squared is the area of a circle. So when we put the 2 in front of pi r squared, that's accounting for our circle top and our circle bottom on the cylinder. We want to add that to length. It's going to be length of the rectangle times pi times the diameter. Now, when we say length of the rectangle, you might be thinking, hold up, what are you talking about rectangle? We have a cylinder. Well, you're right, but remember, if we were to unfold this cylinder and smash it down so that it's flat, we would have a net figure. So we would have what's called the figure's net, and it would look like this. So we have our circular top, our circular bottom, and then this outside of the cylinder is really just a rectangle that's wrapped around it. So if you're wondering where those numbers come from, that's where they come from. You might not be wondering, but so now at this point we can go ahead and start plugging in. So I'm going to have 2 pi times the radius. Now the radius they give us, right, because the radius is halfway across. So it's going to be 4.3 squared, and my parenthesis. And then we're going to have the length, which in this case is 8.6 times pi times the diameter. Well, hold up. They gave us the radius. They didn't give us the diameter. So what are we going to do? Oh, we can't do it. No, we can do it. So you just have to know how radius and diameter work. So if radius is halfway across the circle, then all the way across the circle is going to be 2 times the radius. So we just do 4.3 times 2. Would you look at that? Our diameter is the same as the height. Very interesting. Now that we have that information, all we have to do is plug into the calculator. So this is the easiest part. But you want to make sure that you're getting it into the calculator correctly. So I'm putting in 2, parenthesis, pi button, parenthesis, 4.3, and parenthesis squared. And then another parenthesis. All right, ooh, I see that I forgot to put an add here. That makes a big difference. Oh goodness, okay. I'm going to do it in green so you can see. I need an add here. So there's my addition sign. If we don't have that addition, it's going to give us a very different answer. So there's that addition sign. I'm going to put that into my calculator. And then parenthesis 8.6 pi button and 8.6 and parenthesis enter. Okay, when I do that, I get 348.528289. If we are rounding to the nearest hundredth, that's going to give us approximately 348.53. Let's not forget our label. So inches squared, right? Because anything area is squarea. So there's our answer for surface area, and it'll drive me crazy if I don't put it in up here. So 348.53 inches squared. All right, and that's all for number 3.